Hello, everyone. You're welcome to Pharma Solution. Welcome to this YouTube channel. And if you're new to this channel, I would just want to plead with you that you should subscribe to this channel and you should hit the notification bell and like so that whenever we have new content, new educative videos, you will be the first to receive a notification. So today we are going to show you how to start or to get started with LTSPICE and to build a little circuit and simulate a little circuit with LTSPICE. So this is LTSPICE latest version 2026. You can use any other old version that you have. So to get started with LTSPICE, to open a new project, you need to go to File right here at the top left, and you click on File, you go to New Schematic, and here is our project page. And on LTSPICE, you have different icons, You have different icons right here. Here you have components where you can select the components which you want to use to build a circuit. Here you have diodes, inductor, capacitor, resistor, ground, voltage source, the wire, and all the like. So we are going to build a little circuit and then we simulate the circuit here on LTSPICE to see how it works. So we are going to build a little buck converter circuit. So a buck converter is a DC-DC converter that steps down a voltage from high value to a lower value. So a DC-DC converter that converts voltage from, let's say, about 400 volt to 200 volt is a buck converter. Maybe 200 volt to about 100 volt is a buck converter. Maybe 50 volt to about 2 volt, whatever value is a buck converter. It just depends on the components, how you manipulate the components to obtain your desired output for a particular application. So a buck converter consists of components like the transistor, a diode, an inductor, a resistor, which is your output load, a voltage source, which you want to step down or you want to convert from high value to a lower value at the output, and also an input signal that uh, activates the gate, that polarizes the gates. So next we are going to select our components right here. Yeah, sorry, I didn't introduce myself earlier. My name is Joseph. So we are going to pick our components right here. So the first component we are going to select here is our transistor. So actually, I like using a particular transistor, this arrow GW 60TK65. So the first thing, let me start it all over. The first thing, you go to component, you click on component, and here I have already downloaded library and installed, put the library of the particular transistor which I want to use in this LTSPICE. So that transistor is right here. So I will go where I saved that transistor in my directory. So I will locate it. This is it here. I click it and I click on place. So it will automatically appear and I will click on this. I will left click on this schematic plane where we are building our circuit. So I will click here and one will appear and LTSPICE will uh, give you another privilege to put another somewhere, but because I need just one transistor and I don't need any other one again, I'm just going to press the escape button of my computer and this transistor will disappear. So I'm pressing the escape button now. It is gone. Good. So next I'm going to pick my diode. This is a diode here. I pick my diode. But now I want to reverse this diode to be upside down to 10 so that the cathode can be up and the anode down. So I am going to press the control button of my keyboard and press arrow to rotate the letter arrow to rotate this diode. One time, 2 times. Good. So I will now move my mouse and I click. I will place it there and then press my escape button for this other diode to disappear because I just need one diode. I don't need to place another diode again. Otherwise, if I click again, this diode will still appear here, another diode will be placed there, but I don't want 2 diodes. So I will press the escape button to remove this third diode, and then I click on this. This is the delete or the cut icon. I'll left click on it. This scissors will appear, this icon of the scissor will appear, and then I will come to this object and left click on it. It will disappear, and I will press the escape button of my laptop or my computer, and this will return me to the original form in which I want to continue building my circuit. So this scissors icon will disappear when I press the escape button of my computer. Good. Next, what we need is an inductor. I click on inductor, but now I want this inductor to be horizontal. So I'm going to do same thing, press the control button and I rotate it. I press the control button and press arrow to rotate, the letter arrow. Yes, good. Now it is there. I press my escape button. And next I need a capacitor to place at the output that will help to smoothen the voltage that will be outputted. So next I'll click here. Capacitor is placed. I press my escape button. Next I choose the resistor. I put it in parallel. This is my resistor, is like the load, which I want to view the output. So I'll click escape and it goes away. Next is for me to do my connection. This is a wire icon. I click on the wire and this grid will appear, this snap will appear. I will come here, click here, I will draw, and this other square box, I click. The connection is made. Next, I will come to this square box here. I click there, left click, and I go here where I want to connect. I left click again. The connection is made. Next, I come here, I click. I move to where I want to connect. I click here. I want to bring this down, this wire down. So I will click at this point. When you look at the grid, you see how it matches straight with this line where I want to connect. So I will click here and I bring down the wire to this square and I click there. Next, I pick it from this point where I want to continue to the right. I click there and I pull the wire here. It matches with the square box. I bring it down and I click here again. Connection is made. Next, from here, I go this way to the left, move, click here. Next, from here, go like this, from here to here. Good. My connection is made. So the next thing for me to do is to place my input voltage source, which I want to step down. So I will go to components, right? And I will go to all, click all, then I type battery. I choose my battery. I will put it here. At the same time, instead of going to component, you can directly pick a voltage source here. You just pick and you place it. Very simple. But let me use the battery. So you can do whatever you want. You can choose it directly from there, or you can go to component and select what you want to pick. So next, I will do a connection from the battery to the collector. Oh, sorry. Let me press escape so that I can bring this back up. It has gone down. It has been zoomed. So if I zoom this, I scroll my mouse backward. If I scroll my mouse backward, it will be zoomed in. And when I scroll I scroll my mouse forward, it will be zoomed out. Okay. So next, I'm going to take my wire, connect from here. I want to connect to the collector of this transistor. This transistor is the RG W60TK65. Is a transistor which has a collector, gate, and an emitter. So that is a collector. I have connected to the collector. Next, I will take this negative potential and I connect to the common here. So here I want to put my ground. I'll put my ground here, and next I click here and I connect the ground there. So the next thing we have to do is to do what? Is to put a pulse, an input pulse for this transistor to come on, because like this, the transistor will never come on. You need to activate the gate with a pulse. So when a square pulse, we are going to generate a square pulse. I'm going to show you how to generate a square pulse to activate this gate so that when the transistor comes on, this transistor will act as a switch and current will flow from the source through the transistor to the inductor and to the output. So we are going to build an input pulse into this transistor gate. So what we need is our voltage source. I can choose my voltage source here now. Okay, click escape. I need a resistor, an input, a gate resistor to this transistor. Let's rotate it as usual. So I'll put my gate resistor here. And from the datasheet of this transistor, the gate resistance was stated to be, uh, that should be 5 volt. I think that should be 5 volt, 5 ohm, sorry. The gate resistance should be 5 ohm. So you can confirm that with me if it is 5 or it's 10 ohm. So I will change that. I will right click on it and then I write 5 here and I click enter or OK. And I will connect this to this, this to this, this to this. Now I need to give a pulse to a square pulse, a rectangular pulse, sorry, to the gate of this transistor. So I will right click on this voltage source. I'll right click and this uh, menu will appear, this box will appear. Then I will go to advanced, click on left click on advanced, sorry, left click on advanced. And then I will choose pulse because I want to generate a pulse and this will appear. So they said initial voltage, since it's a rectangular pulse, I want to start from 0 and climb to 15 volt because according to the data sheet, the gate voltage should be 15, at most 15 volts. So I want to start from 0. I'll put 0 here, initial voltage, V on. For it to come on, I need 15 volts. The delay time, what is the time before it starts rising? I will take 1 micro second, the pulse start rising, and then the rise, T rise, I want to take 10 micro, T fall, 10 nano, sorry, let's put 10 nano, T fall, let's put 10 nano, T on, how long should it be on? Let's put 5 microseconds, and the period, let's put 10 microseconds. That is going to be a very high frequency, you know. Yeah, so we click OK. And these are the parameters that have been set that has automatically appeared here. So we are going to move this. Let's click on move. We are going to move this a bit right here so that we can see clearly. Yeah, so we move this right here. Good. Next, we are going to set in our input voltage here. So the input voltage, let's choose 200 volts. So when you right click there, you right click here, you write 200 volts. Okay, good. So this is 200 volt that has appeared here. So let's try to move it to put it exactly where it's supposed to be. Good. So next, we are going to put the value of the inductance. Let's choose, we right click there, let's choose about 56 microfarad of this inductance. We click OK. The capacitance, let's choose about 40 microfarad. The inductance 56 microhenry, capacitance 40 microfarad. Then the resistance, let's take about 4 ohm. We want it to be as small as possible so that we can really appreciate our output. So that is set and done. Next we have to do is just to run the circuit. So let's first of all save our circuit before you start building your circuit. Make sure you always save it. Always save it. So let's save it as let's call it book1.asc. Always make sure you put .asc. You click on save. So we are going to run this circuit. This is where you click before we go there. This is the run icon. Run. You click on it, this dialog box will appear. So you put, let's put 2, tran 2 will appear here, .tran, here will be .tran2. And when you click OK, this will appear on your simulation. And then you have the output panel where you are going to view the display of your graphs, your waveform of voltage and current through the components. So I am going to divide this into two because I want to view voltage at one section and current at the other section. So I will right click on this panel for the graphs, right click, and I go to add plot plane above. I click left click there. And then when I click here, up here, I want to view the voltages. So I'll click here and then go to the circuit. I want to view the input voltage. When you bring the prop here, the cursor here, and this prop will appear. You click on it. This is the input voltage, 200 volt. You see it's constant, increasing constant. Next, excuse me, I want to see what is going into the gate. The poles that I've generated, the rectangular poles, I want to see if it is indeed generated. So I'll click here. You can see it is at a very high frequency. So let's try to zoom it. Let's try to zoom and see how it looks like. Let's zoom further. Let's zoom further. You see, it looks like a rectangular pulse. See how it increases from 0 volts to 15 volts. Good. So next, let's just run it, stop it and run again so that we can appreciate all the other components, outputs. So I am going to undo. Good. Okay. So I want to bring it back to how it was. Next, let's look at the current, the voltage at this terminal. So I want to view the voltage here at this terminal. The voltage output here, this is it, the red graph. And let's look at the voltage at the output across the resistor. This is it here. It has appeared in this kind of a faint. It looks like a cyan color, something like that. I'm not good with colors. So you see that. And now let's go to this other part. Let's view the current through the inductor. I will click here and I'll go here in the circuit. Let this ammeter, the clamp meter, this clamp appear, which you can bring closer to the inductor, and then you left click there. Let's view the current. This is the current. You see the current first of all spiked to about 3.6, the transient, and then comes to the steady state. And then let's see the current that is going to the output, the resistor also. This is a current also moving like this. So let's try to zoom and see how this looks like. Let's zoom further. How the voltage, we can really appreciate the voltage and the current. So you can see it right here. This is the current output. This is a current through the inductor. that looks like a sawtooth. And then when you zoom further here, you can see how the output voltage looks like. This is VN04. This is a pulse, the input 15 volt, and then the output, this should be the VN04. Let us find it, VN04, this red one, where it is here. I'll need to move VN04, the node VN04, okay, is the voltage at this point, just at the output here entering to the inductor. So that is the voltage. And then here you have the output voltage. The output voltage, it is increasing. It starts and it is increasing. So the output voltage is based on the manipulation of this inductance. So you can manipulate this inductance to get whatever voltage that you want at the output. It's just by doing your calculation very well and then manipulating the value of this inductance to get the desired output voltage. So that is it. And thank you for watching this video. And I would like you to like, subscribe, and follow us. And do not forget to comment also in this channel whatever question you have, whatever comment you have to make. I think that is going to help us a lot. Thank you very much, and see you again in the next video.